Designing a network forces a direct choice between access and protection. You could build a completely open system where users connect instantly, or a highly restricted environment that requires clearance at every step. Security is an exercise in compromise. When you implement maximum protection, you inevitably increase the financial cost to the organization and the daily hassle for the users. To determine how much friction is appropriate, network managers evaluate data sensitivity. If a network only hosts an open public dataset, like a school lunch menu, it requires almost no security. The data has no critical value, and locking it down only frustrates students. This table, however, shows a highly sensitive company dataset. Because it contains employee salaries and private home addresses, the company has a strict legal and ethical responsibility to ensure it cannot be accessed by unauthorized users. The network manager must evaluate what the system holds and choose security tools that perfectly match the sensitivity of that data. The first tool deployed is usually a firewall. Acting like a digital bouncer, the firewall automatically examines all incoming and outgoing network traffic, blocking suspicious activity while letting safe data flow uninterrupted. But firewalls do not stop everything. If an external packet arrives presenting authorized credentials, the firewall assumes the traffic is safe and willingly lets it inside the network. Because firewalls let credentials through, those credentials must be protected. Hackers regularly run automated brute force attacks, using software to guess millions of password combinations per second until they find a match. This policy checklist outlines how to defeat those attacks. By forcing passwords to contain random symbols and extending the length past 10 characters, the number of possible combinations becomes too massive for a brute force algorithm to guess. Firewalls block the digital noise, and complex passwords stop automated guessing. Yet, if an authorized user is tricked into revealing their password, the network is left entirely vulnerable. A stolen password renders the firewall's filtering ineffective. Because the incoming connection request presents legitimate credentials, the system accepts the traffic and grants full access to the network's resources. To prevent a stolen password from granting immediate access, networks use two-factor authentication. This acts as an emergency stopgap, freezing the login process until a secondary check is completed. Effective two-factor authentication requires a secondary form of evidence beyond a password, specifically a physical item in the user's possession, such as a unique code sent to a specific smartphone. This keywords box highlights an even stricter method of verification: biometrics. By scanning unique physical traits, like a fingerprint or facial geometry, the system can mathematically guarantee the identity of the person logging in. Let's apply this. Imagine you are managing a coffee shop network. You have a free customer Wi-Fi connection and the manager's digital cash register. Pause the video and decide what level of security each requires. The customer Wi-Fi holds no sensitive data, so it stays open for maximum accessibility. The cash register processes financial data, requiring a strict combination of firewalls, complex passwords, and two-factor authentication. In practice, threats attack networks from multiple angles. We secure them by building a layered defense. The firewall blocks the obvious external threats, the password policy stops the guessing algorithms, and biometric or two-factor checks stop stolen credentials. Because no single software or hardware tool is flawless, layering them ensures that one tool's weakness is covered by another's strength. Every design begins by evaluating data sensitivity. The manager then scales the network's defenses, choosing the right combination of tools to match the threat level. True network security is about maintaining that exact balance, deploying enough friction to protect the data without making the system impossible to use.